Good day, Niners. In this video, we will be graphing a hyperbola. We have here a hyperbola already written in the correct standard form. You know this is hyperbola because that's a minus. If it were a plus, it would be an ellipse, and you know how to do that already. It's a minus, so it's a hyperbola. So before we start graphing, you have to be sure of the correct orientation of your hyperbola, whether it be opening horizontally or vertically. You know that a hyperbola will be horizontal like this. You see the relative positions, the center, the vertices, and it looks like you have two parabolas opposite each other. It's horizontal when it's like this. And the standard form will have a horizontal graph if notice that the positive term is the one with x. So if the positive term is the term with y, like in this case, you will have a vertical hyperbola. Very important to remember here is that whoever is the positive term will have under it the length of the transverse, the semi-transverse axis A. Always remember A should be under what is the positive term. In this case, A is under x. Here, A is under y. And now let's begin graphing our hyperbola. You know that this hyperbola will be horizontal since the term that is positive is x. So let's have the lengths of these important parts, the semi-transverse axis. This is the counterpart of the semi-major axis in your ellipse, so it's also A. So A is equal to 3. Of course, A squared is 9. The semi-conjugate axis is the counterpart of your conjugate axis also in your ellipse. So B is 4. So the semi-principal axis C would be, now, in a hyperbola, the relationship between the length CA and B will be this. C squared is A squared plus B squared. In the ellipse, you know that the relationship is A squared equals B squared plus C squared. In hyperbola this time, C is your longest of the three lengths. So this would be 5. Now, let's begin with the center. The center of the hyperbola is of course HK. So it's negative 4 and then 1. So let's plot the point. Negative 4, 1. 1, 2, 3, 4, 1. Now, know that this is horizontal, therefore, the transverse axis should be also horizontal with length 6 units, 2A. So 3 to the right and 3 to the left would be the endpoints of the transverse axis. 1, 2, 3, 3 here, and 1, 2, 3 here. These points are also your vertices, since this would be horizontal. So ordinates are, so the 3 points will have the same y coordinates. So this is also 1. 3 units to the right of negative 4 is negative 1. 3 units left of negative 4 is negative 7. So just subtracting. Now let's plot and locate the endpoints of the conjugate axis. So 4 units above the center, 1, 2, 3, 4. And 4 units below, 2, 3, 4. Will be the endpoints of our conjugate axis, and just let's label them as B1 and B2. So B1 would be, so the center and the endpoints of the conjugate axis will have the same x coordinates, so it's negative 4 also. So in this case, we are moving 4 units above the point, so 1 plus 4, that's 5. And then 4 units below the point would be 1 minus 4, negative 3. Now, if this were an ellipse, we will just be connecting these points like that if it's an ellipse. But we know this is a hyperbola. So an adjustment has to be made, and the only difference that instead of connecting these points like it were an ellipse, we will draw what we call is a reference rectangle. So we will draw this reference rectangle wherein the midpoints of the sides will be our endpoints of the transverse and the conjugate axis. Now, connecting the diagonals of this reference rectangle, passing through the center, extending it, would be our asymptotes. So hyperbola is as an asymptotic behavior, it's asymptotic to these lines. So let's just draw them first, and I'll explain later. So you have here the asymptotes, passing through the diagonals. And now, to get the endpoints of the focus, the coordinates of the focus, F1 and F2. Since this is horizontal, the focus is also horizontal. The principal axis is also horizontal along this horizontal line. And it's 5 units away from the center. So the center is negative 4, 1. So we have the same y coordinate, 1. So but this time 5 units left of the center. So it's negative 4 minus 5. That would be negative 4 minus 5 is negative 9. And 5 units from this point, the center, 1, 2, 3, 4, 1, 2, 3, 4, 5, that's 1. Or simply negative 4 plus 1. So this would be the focus. Focus 1 and focus 2. Now we have to get the endpoints of the lateral recta or our ELRs. So we have 4 of them. 1, 2, 3, 4. So we have ELR 1, 2, 3, 4. So the length of the latus rectum in a hyperbola is the same as that of an ellipse. The length of the latus rectum in a hyperbola is also 2b squared over a. So meaning the latus rectum would be a segment perpendicular to the transverse axis, passing through the focus. So we will be dividing it into 2, b squared over a above and b squared over a below. B squared would be 16 and a is 3, therefore 16 over 3 units above this point would be the endpoints of the latus rectum. B squared over a is 16 over 3, that's around 5 and 1/3. So 1, 2, 3, 4, 5 and 1/3, that's an endpoint. And 1, 2, 3, 4, 5 and 1/3, another endpoint. So it's the same in the other side. So just locate them. Okay, now the coordinates of these points, they have the same x coordinate as the foci. So we just copy negative 9 here, the negative 9, and then the other is 1, 1. Okay, about the y coordinates, the y coordinates would be 16 over 3 above this point. So 16 over 3 plus 1, that would be 19 over 3. So it's same here, 19 over 3 in the other side, in the right side. Then the y coordinate for these 2 points would be 1, 16 over 3 below, that's 1 minus 16 over 3 or negative 13 over 3. So negative 13 over 3. Okay, now we can now simply connect these points, the vertex to this endpoint, vertex to the other endpoint, drawing our hyperbola. Okay, but we will complete first the other parts. The directrices. The directrices of a hyperbola that is horizontal in nature is of course like here we have horizontal hyperbola. The directrices would be 2 of them would be there, they would be vertical, just like in a parabola before. If a hyperbola is vertical, the directrices would be horizontal, like that. And it's the same. The directrices of a hyperbola are a squared over c away from the center. So the center, since the directrices are vertical, the equations are x is equal to, so from the center, which is negative 4, we will simply add and subtract a squared over c, which is 9 over 5. A is 3, therefore a squared is 9 over 5. Now, we can simplify this, but just leave it as is. Negative 4 plus 9 over 5 would be negative 20 over 5 plus 9 over 5, or negative 11 over 5. And that's negative 2 and 1/5. 1, 2, and 1/5. This would be the first directrix. 1, 2, and 1/5. Then the other directrix would be negative 4 minus 9 over 5. That's negative 29 over 5, or very close to negative 6. So you have 1, 2, 3, 4, 5, 6. So very close to negative 6. So there you go. These are the directrices. Now, what we're missing are the equations of the asymptotes. So the asymptotes would be these two lines, these two diagonal lines that will pass through the center. So you know that we have a point, we need the slope to get the equation of these lines. And the equation of these lines will simply be the rise over run of the slope. In this case, our rise from the center is 1, 2, 3, 4. That's exactly our B. And then 1, 2, 3 run, that's A. So the slope of this positively sloped line is 4/3. So the other must be negative. So just write the equation of your asymptotes as the equation of a line passing through a point with a given slope. So y minus y sub 1. So our y sub 1, of course, is the point it will pass to the center, y minus 1, equal to the slope plus and minus 4/3. Again, the slope is we got that from rise and run. 4/3 of x minus the point, which is negative 4, so x plus 4. So there you go. We have here the completed parts of hyperbola: center, vertices, foci, endpoints of conjugate axis, latus rectum, directrices, and asymptotes. Now we will draw the hyperbola. Okay, this is the tricky part in drawing. A bit as a blue line from the vertex. There you go. There you go. Passing through that point. And I said earlier that the behavior is asymptotic. Therefore, it will just touch the line. It will come very close to the line, but it will not touch it. So do the same in the other. Okay, it's very hard to draw here. So yes. So passing to that point, and it will be asymptotic to the line. Said these are asymptotes. You know, this should be a smooth curve, but I'm trying my best. So let's have the other. I'll do this one. See, locus of a point that moves. So it's moving point passing through that. It's asymptotic. You see, get the point. The left side is much better than the right side. So passing to the end point of the latus rectum, there you go. So bird says here. Yeah. See. Now, let's remove the reference rectangle so you can get a clear picture of the hyperbola. So you see, these two vertical lines are the asymptotes. These two vertical lines are the directrices. I mean, these two, directrix 1. Let's remove the directrix. Remove that directrix. The asymptotes are just here to guide, because again, I said the hyperbolas have asymptotic behavior. They will come very close to this line, but they will not touch this line. You see, this is the center of your hyperbola. These are the vertices, the foci, and notice that these 2 points are actually not part of your graph. So let's erase them. There you go. This is your hyperbola. So I suggest you practice draw this more better than I did. I'm sure you can. So that's it. Good day, Niners.